Rosario Otis. Hello, how are you? Hello, can you hear me?
Yes, good morning.
Well, how are you today?
Good, how are you?
Getting better. All right, so in my message, I explained well, I'm still not feeling strong enough. I'm having a flu since Sunday, so it's still not haven't gone yet. So but I still want to make sure that we have our classes. So that's why I kept putting this to make sure that we don't miss a lot. Now, today we continue from where we stopped here on Monday. We are now in probability. We continue from there. I'm trying to get all your names. And I have, please, if you don't hear your name, let me know. I have here, I got Marvelous. I got Curtis, Ania. I got Jonathan Forbes, Ashley Johnson, Gabriella Johnson, Ania and Ali, Michelle McHoney, Haley Rosario, Gemoni Roy, and Nyla Stalin. Is there somebody that I mentioned the name here?
Yes, Anad.
What's the name, sir?
Anad.
Anad. How do you spell your last name?
Bowens.
Oh yeah, Anad. I see it. Okay. Any other person?
You said my name.
Yes, I say your name, Gemoni. Who else? I didn't say the name. So we are good then. Okay. Excellent. So let's begin. Have so on Monday we stopped here. So on Friday we do the same thing on Friday because I still not. So this week, all of this week will be on Zoom. But next week I will bounce back and we'll go back to the class as usual. So I remember I mentioned we started probability and I gave you some examples on probability. Even the classwork was also on probability. So let's continue. Suppose you are given this. Before we continue, let me refresh your memory about what probability is. Simply put, is the chance, the likelihood of an event occurring. So when we try calculating the probability of an event, the general formula we use is the chance of that event occurring divided by the total possibilities. The possibility of that event occurring divided by the total possibilities. So something like that. See, number of ways E occurs, then total number of outcomes in the sample space. So that is the general formula we use. And this is for classical probability. That is where we stopped last time. So now let's start the example here. This example says a roulette. I'm sure you all know a roulette. If you don't, this is how it looks like. It's a roulette is a gambling machine. I'm sure that by now you'll be asking yourself, why am I giving you all these examples that involves gambling? Well, the principle of probability was actually developed by gamblers. So eventually it was discovered that these principles can actually be used or applied in other fields of human endeavor. So that's then we started applying it in different fields, in education, in health, in business. So that's why we see many examples we are using come from the gambling. Anyway, back to that, we say a roulette wheel has 38 slots, numbered 0, 0, 0, 1, 2, 3, all the way to 36. So half of 1 to 36 are red, and the other half are colored black. As you can see from here, half of this, see where you have the numbers, half are red, and the other half are black. Then there's the remaining 2 that are the 0 and 0, 0 slot are colored green. You can see, right, 0 green, 0, 0 green. Okay. Then it says, find the probability that a ball lands on a black number, B, a green number, then C, it's a 10, then D, an odd number. Okay. See, a black number, a green number, a 10, and an odd number. What is the probabilities for this? So that's what we are looking for now. Okay. So solutions. Now, it said that the slots are numbered 0, 0, 0, then 1 to 36. That means we have 38 slots. So half of that, from 1 to 36, from 1 to 36, half of that is 18 are black. So B is black, 18. Another half are colored red. Red is 18. Then we got the 0, the green ones are 0 and 0, 0. There are 2 of them. 2. So the sample space becomes, you add all these 3 numbers. Let me write them down. I write this down. Oh yeah, that's the book. So you add 18 plus 18 plus 2. So I can just for you. 18 plus 18, 18 plus 18 plus 2 give us 38. Okay. So the sample space here is 38. Now, with this, we can answer the equation. The first question says, find the probability that the ball lands on a black number. That means P, this P here represents probability. B represents black numbers. So you're gonna be, how many black numbers we have? How many? We have 18 out of 38. So that the probability that it falls on the black number is 18 black numbers, 18 slots, like a block out of 38 slots. And that gives us 18 or 38. So that we have 18 divided by 38. Give us 0.474. 0.474 rounded. 0.474. Or you can call it 47.4% chance that it will land on the black number. So the next question says, to find the probability that it will land, the ball will land on the green number. We have, if you look at here, we have 2 green numbers. So that the probability that it will land on the green number is 2 out of 18, out of 38 numbers. I mean, it's 2 out of 38. Pick 2. I pick 2. That give us 0.053. Give me 1 minute. Let me put this. Say Julation. Okay. Oh yeah. Okay. All right. So 0.053. See, when it is actually 0.05263 continue. So when you round it to 3 decimal places, it's gonna be 0.052. 0.053. Okay. So you got 0.052. 0.052. Or if you like, I can call it 5.2%. Okay. Then last one says, sorry, not the last one, part C. Part C says the ball lands on a 10. Part C. On a 10. If you look at this, excuse me, there's only one 10 here. See, look, there's only one slot that has it, number 10 on it. It's right here. See? Only one has 10 on it. See right there. So that the probability that it lands on the 10 is 1 out of 38. Which is, if you go here, the calculator change this to 1 over 38. So 0.026. Okay, 0.026. 0.026. Or if you like, you call it 2.6%. See, if you ask me, I would say that these are good odds, because if there are some games that if you check their probability, you just go crazy. Something like this in Mega Million, the probability is not even up to half, not even up to 0.01%. But these ones you can see they are good odds actually. This is that the ball in an odd number. Well, odd number is half of the 1 to 2 36 odd number, which is 18. So you gotta be, so the probability that it lands in an odd number will gonna be 18 out of 38. Okay, and that will give us 18 over 38. 18 divided by 38. 0.474 rounded. 0.474 rounded. 0.474, or like 47.4% chance. So any question on this? Any question? Hello, class. Do you have a question for me?
Can you scroll down a little bit, please?
Sure.
Like right there, yeah. Okay, thank you.
You're welcome. Any other question? Yeah. All right, that's good. So now let's look at the next questions here then, since there's no question. Now let's look at the there's some of the basic probability rules. The basic probability rules. For that, I will take you down a little bit. Look at those basic probability rules that I want to show you here. So what? Just 1 minute. Let me put this name in. Jadine. Okay, let me put it in. Admit him. Okay. So this is the first rule. The first rule says that rule 1 says that the probability of event E is a number, either a fraction or a decimal or a percent, but it is a number between 0 and 1. That means between and including 0 and 1. So this is how we write it. Probability of event E is greater than or equal to 0, less than or equal to 1. This means that the probability of an event can never be negative, and it can never be greater than 1. So if you are solving a probability question and the answer is greater than 1, then the answer is wrong. Now, please don't send me text on the chat box. If you want to ask me a question, ask me in the classroom here, okay? Now, so if you are doing a question on probability and the answer is negative, then the answer is wrong. So it can never be greater than 1 or less than 0. The second rule says, if an event E cannot occur, then its probability is 0. Which means that the probability of an impossible event is 0. For example, if sitting down is an event and standing up is another event, the probability of you sitting down and standing up at the same time is not possible. Is 0. Not possible. Who is this person? Quena. Who's Quena? Okay. It's first time I've seen him. Okay. Now, part C says, if an event E is certain, that means that you are sure that it will happen, then the probability is 1. That is, probability of event E is 1 if the event is a certain event. Now, you know we have night and day. So if we have a night, then we have the day will break. So that the probability of a day break is, everybody know that the day will break by 7 a.m. at least, is 1. Then we have what we call complementary events. Their probability says the complementary probabilities. I'm gonna explain it in a different page. So these are the basic probability rules. Now I can take you back to where we were before. We come here. We were in here. So now let's look at the complementary events. To the complement of an event, E is the set of outcomes in the sample space that are not included in the outcomes of event E. So, which means that if E is an event within the sample space S of an activity or experiment, then the complement of E is written as this as E complement. Now let me use a picture to show you what I mean by that. Suppose you have a suppose you have this here. We have this okay as event. Okay, we have another event inside it. It's another circle. Okay. Let's say that this is event A. Now, the complement are these ones. Give me 1 minute. Let me see if I can okay, format it. Make it okay. Let me see this if this will work. Didn't work. Okay, let's say this. So this is I'm going to use a different method. These are the complement of event A, the shaded part are the complement of event A. Yeah. You notice that A is not shaded. All the shaded parts represent the complement of A. See? They are not part of A. Now, I will give you an example in real life. Now, suppose that those of you who are here today, their complement on being here today is you not being here today. If you are sitting down, your complement of you sitting down is you standing up. So it's basically the opposite of what you do. See? All the shaded parts are the complements of event A in this chart. See? So that the complement of A, complement of A include all these shaded parts. All these shaded parts. See? All of this. Okay, I think I missed it. My God, delete it. Delete it. So the complement is all these shaded parts. See? All the shaded parts. This is A right here. See? So the complements are not included in A. So now the complement of coming to class is you not coming to class. The complement of having a bank account is you not having a bank account. So the opposite. So let's answer some questions about complements now. It says here, find the complement of each event. Getting 1, 2, 3, 4, 6. See? Find the complement of each event. Say getting A phase, getting 1, 2, 3, 4, 6. Let me see why this thing gets. Oh, you know, this is I'm gonna remove this part. So A says selecting a letter of the alphabet and getting a vowel. It means vowel. There are 5 vowels in the English language. So the opposite of not getting a vowel means getting B, okay, B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. See, that's a complement. That means not getting a vowel or getting what they call consonants. B part says selecting a month and getting a month that begins with J. Answer means getting a month that doesn't start with J. Okay. So selecting a month and getting a month that begins with J means getting months that does not begin with J, but you have to list them. So I mean, getting the following, getting February, February, March, April, May, August, September, October, November, and December. See? So you're gonna see this kind of question in your next assignment, your next homework that'll be available next week. And your second test, you're gonna see them too. Selecting a day of the week and getting a weekday. Now, selecting a day of the week, getting a week. Yes, ma'am. You have a question?
Yes. So I don't know if maybe it's not uploading on my end, but I don't be seeing the PowerPoints. Like when we ask you to upload them, I don't be seeing them.
What PowerPoint?
Like I remember last class, somebody had asked you to upload something.
You mean the one we have on Monday?
Yeah.
Hold on. I think I did. Hold on. Give me 1 minute.
Okay.
I think I did. Just 1 minute. Yeah, I uploaded it. When you log in, you gotta go to the models.
Okay.
You go to the models, and then from there you can see the PowerPoint. But let me make sure, double checking. So this is your class right here. And if you go to the models, you're in model 4. Right here, it's right here. Hello.
Okay, thank you.
Welcome. So anyway, this one says selecting a day of the week and getting a weekday. Weekdays are Monday, Tuesday, Wednesday, Thursday, Friday. So you say getting a weekday, the complement is the opposite, not getting a weekday, which means getting the weekend. That means the answer would be getting the answers, getting Saturday and Sunday. And Sunday. Okay. Any questions so far? Any question at all? Any question? Yeah, we're good then. We're good. Now, at this point, I'm going to summarize the complementary rule, how we use in a formula form. It says, for complement, we use, if you see how we write it here, E with a small c. In some books, they will write it as follows. You can say E, and they put a prime. See prime. See, I think I'll have prime here. I don't see prime here, but they put something like a prime at the top of it. Yes, I don't see prime, but they put something like a small prime at the top of it. But for now, just use EC as a complement. Now, so probability of E complement is 1 minus probability of E, and the probability of E is 1 minus probability of E complement. Okay, so let's apply it by solving one question here. It says, I'm gonna move this down a little bit so that we have enough. Meanwhile, I will yeah. It says, in a lottery game, each player chooses a 3-digit number. between 000 and 999. A player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket loses the game. So you are looking for the probability that somebody loses the game. Winning the game is if the actual thing. Complement means losing the game. And that's what you're looking for. Okay. Now I said this is the lottery game. And the each player chooses a 3-digit number from between 000 to 999. So that we have, that means you're gonna have number digits like 000, comma 001, 002, all the way to the last digit, which is gonna be 999. So that means we have a 1,000 digits as the maximum. 1,000 digits. So the sample space is 1,000 there. Because they're going to be 1,000. If you add 000, then 001 all the way to 999, they're going to be 1,000 digits. Then, he said a player wins if his or her 3-digit number is chosen. So let us use W to represent win. And the opposite of winning, which is the complement, is WC. So by the complement rule, the probability of WC is 1 minus the probability of W. Let's find the probability of that you win. Remember, a player wins if his number or her number is chosen. Right? To win, that means to have the number that you chose, the 3 numbers are all chosen. So you have 1 out of 1,000 chance of winning, which means 1 divided by 1,000. Okay, 1 divided by 1,000 is 0.001. 0.001. 0.001. That is your chance of winning. So the chance of not winning, that means the probability of losing becomes 1 minus probability of winning, which means 1 minus 0.001. And that will give you the complement, which is the probability of losing. So 1 minus 0.001. 1 minus 0.001 was 0.999. You got 0.999. Or you are 99.99% chance of losing. See? 99.999% chance of losing. Any question on that? Any question? Yeah. Now, those of you who have not done their classwork yesterday, submitted yesterday. Yesterday is past. It's already past due. So never mind. Now let's look at empirical probability. But before that, any question for me? Any question? Good. Empirical probability. Now, in a sample space, in the classical probability, that's the one we just did. We know the sample space of the to be 1,000 because it said from 000 to 999. In these ones that we just did, we did yesterday, even now, the roulette, you see that we see the slots. We know that it has 38 slots already, so we know the sample space. But in empirical, we don't know the sample space. So we have to estimate the sample space by ourselves by observing the number of occurrences of the event through experimentation or by calculating the probability from a relative frequency distribution. So these are 2 ways. So for that one, the probability of event under the empirical formula is frequency of event E divided by the total frequency. Let's try this example. It said hospital records. I'm gonna move this down a little bit. Hospital records indicated that the maternity patients stayed in the hospital for a number of days shown here. It says, find the following probabilities. The first one is that the patient stayed exactly 5 days. B part said this patient stayed less than 6 days. C, the patient stayed at most 4 days. E, the patient stayed at least 5 days. So the first thing is to find the total. And if you add all these frequencies, you get a total of 127. So the first question says a patient stayed exactly 5 days. Now look at 5 days right here. How many patients? 56 patients. So that the probability that the patient stayed exactly 5 days become, I see the 5 and the frequency is 56. So it's gonna be 56 divided by total of 127. And that will give us how long the patient stayed, the probability that the patient stayed exactly 5 days. So I'm gonna write this down, 56 divided by 127. Okay. So we got 56. 56 divided by 127. It was 0.441 rounded. 0.441 rounded. So that answered the question that the patient stayed exactly 5 days. The other one said the patient stayed less than 6 days. Less than 6 days. Now look at 6 days right here. So from 5 up are less than 6 days. So that the probability that the patient stayed less than 6 days is gonna be probability of 3 plus the probability of 4 plus the probability of 5. So you're gonna have a probability of 3, okay, plus probability of 4 plus P5. So we cannot say we cannot add probability of C because it says less than 6 days. So that we have it in this form. Equal, we have the probability of 3 is 15. Because this is 3, the frequency of 3 is 15. So you got 15 over 127. That 15 over 127 plus next one is the probability of 4. See 4, this is the frequency 32. 32 over 127, which is the total right here. 127. Okay. Plus for 5 days, we got frequency is 56. 56 divided by 127. Okay. And that will give you the answer for that the patient stayed less than 6 days. So let me write this down. I got 15 over 127 plus 32 over 127 plus 56 over 127. So we go here, we have 15 divided by 127. Yeah. Plus 32 divided by 127, and plus 56 divided by 127. 0.811 rounded, 0.811. See? Any question on that? No question. Good. So let's try another one. It says the patient stayed at most 4 days. At most 4 days means 4 days or less. So that the probability that he stayed at most 4 days is gonna be 4 days or less. See, 4, that means 4 and 3. See, that's gonna be that the probability that the patient stayed at most for 4 days is gonna be probability of 4, that means 3 plus probability of 4. Okay, that means equals, go here for 4 days. 3 days we have 15 for 127 for 3. 15 or 127, 15 divided by 127. Okay, plus that next one will be 32 by 127. 32 by 127. Okay, plus we got, oh, that's it. Only 2 of them, and that will give us the probability. So we go here and find it. So we just gotta remove this one here. Yeah, that's a 0.370. 0.370. Yeah. Then the last one says the patient stayed at least 5 days. See, this is 5 days. At least 5 days means 5 days or more. That means probability of 5 plus the probability of 6 plus probability of 7. So the patient stay at least 5 days means 5 or more. P5 plus P6. Excuse me. Plus P7. Which will give us equal the 5 days. We have 56 over 127. 56 over 127 plus for 6 we have 19 over 127. 19 over 127 plus last one is gonna be 5 over 127. 5 over 127. That will give us the final answer that he says. Let me write this down. 56 127 plus 19 over 127 plus 5 over 127. That was the probability that the patient stayed at least 5 days. Okay, we have this 56 divided by 127. Okay, plus 19 over 127 plus 5 over 127. 0.630. Rounded. 0.630. Any question? Any question on this? Yeah, no questions. So I will see you on Friday then. See you. Remember Friday we're going to have remote class again, because that hopefully by this Friday I should be stronger, but much better, so that by Monday we'll resume our classroom sessions. If you don't have any question, then I'll see you on Friday then.
Oh, I have a question.
Mm.
Is it going to be the same link used today for Friday?
Yes, it's only we used today for Friday. Yes.
And you'll also be posting this work onto Canvas, right? Like
Yes.
the one we did in class, to use an example.
Yeah, just go to that same link that I showed you today,
Okay.
and it's gonna be there.
All right. Thank you.
You're welcome.
Have a good day.
You too. You guys have a nice day.
Thank you.
you.
You're welcome.